ready?
Ready? Go.
Okay, all right. Okay, so we're running the Western blot on some extract from cell lines. Okay, so let me just explain how we did this. Yesterday we made extract from A20 Ramos HEK cell lines, and we made the extract in the buffer, in the lysis buffer, made fresh lysis buffer, right? But then one of them, when you lyse the cells, there was little DNA in the Ramos and HEK. So he pulled that out, because I know that's not there. So that was okay. Okay, then we have the extract. And then we did this, let me see, there was a protocol, this guy, yeah, it's not on here, but the
BCA protein assay.
Right, BCA protein assay. So the BCA protein assay, we took, there's a standard, albumin standard, that is at, I think, 2 milligram per mil. And so there we took no dilution, 1 to 10, 1 to 100. And then using that BCA standard, which worked very well, you make the little mix, and then you make it, put it together, and then you heat it for a half hour, and then heat it for 5 to 10 minutes, and then a half hour. Anyway, there's a protocol, and it worked well, and it converted the color, and we have some pictures of that. And then we did the 3 standards, just whatever the sample are, and they turned out to be these numbers here, like up to 0.5, 1.2, kind of concentrated. And then, but then we take the 3 standards and we get this curve, and our samples are all around this value right here, which is sort of on the curve, almost off the curve. But when you calculate it out, it turns out that they are this concentration right here, 24, so I don't see the value, so we got the concentration, oh, here it is, 0.8, 1.0, 1.2 milligram per mil, just what it turned out, or 800, so forth, 1,000, 1,200 microgram per mil. Surprising, because the HEK had the DNA in it. So these are the concentrations. Now for the gel, we wanted to load 20 microgram, and then that's the maximum, or 10. So we did 3 separate loadings, 20, 10, and 10 of A20 Ramos and HEK. And that turns out to be a certain volume, which is 24, 20, and 16 microliters. So we calculate for three samples of that like that, we want to take 24 microliters, 72 microliters of these microliters, 72, 16, 48 of this extract. So we took that out and we aliquoted the rest. So froze it in dry ice, put it in the freezer. So that we can use again. So this is what we do. Now we got 4x sample buffer, and we actually have that sitting out here somewhere. 4x, anyway, the 4x sample buffer went away. So, and here it is, 4x the melee buffer. So we take that, and we have some 2.5 molar or 5 molar DTT, freshly dropped in liquid nitrogen, so it's very well done and very quickly frozen. And so we made this little table here of if we take, well, first off, you got to make that. So you take this buffer and put in, it's roughly 10x, say, it's 2.5, we want it 2.5 fine for 4x, 50 millimolar final. Okay, so that's DTT. So we took that and mixed that with this, and how much, we figured out how much we need. 60 plus 5 microliters of DTT will be enough to load this. I added these up, but then I added a little more. So then we're set. So we got the 4x buffer, the DTT, we got the samples all measured out, and then we took we made this amount of A20 plus 24, this amount of Ramos plus 20, this amount of HEK plus 16 of the 4x buffer. And then you go into from there, you go into the 95-degree water bath, this for 95 degrees, and incubate for 5 minutes. And what I didn't do, except for the last sample, the HEK, is to take it out of there and spin it. So it's good to get, if there's any junk, we don't want to load the junk. But we spun it, and I think there wasn't anything in the HEK, but I forgot to spin the first 2. And then, very critically, for 20, 10, and 10, we load A20 was 30, 15, and 15. That's 30 microliters, 15, 15 of the final mix. And then the same for Ramos and HEK. So what we have here is the first well is the standard, and the next 9 wells are the different samples, this amount. Now to do that, I took a little bit of the loading buffer and marked the wells. You know, I marked the first well, I think I marked the middle and last well, but actually they disappeared, so I had to do it again. And then I take this critical pipette and set it on, like this is set on 5, but you know, but any event, it's more than that. But take the right amount on this critical pipette. Oh, right, because I was testing the sample. I was putting a little bit of sample buffer back in. But, or this was 5 is how much of the standard that I put on the first well, and then this amount. Okay, but here's a critical thing. It's hard to see the well for me, so I got my glasses, and I think a black or maybe a white background. Black if there's nothing in the well, white if there's already a little dye in there. And then I went down carefully, and well 1, I put in 30. Well 3, no, 1, 4, 15, and 8, 15. So like that. And carefully go down to the bottom of the well and load this. You go to the inside of the glass. What I did, the glass is there, so I went to the inside of the glass, I felt that, and then I went down and could visualize the pipette. Then you carefully dispense out very slowly, and then let it so it sort of settles in at the bottom. Anyway, so I did that for all 3 samples, and this was all set up in advance. I should say, when I took the comb out, I pulled it, you know, see, I always worry about ripping the teeth. So I wiggled it a little bit so make sure everything's loose, and then sort of gently move it back and forth as I pull it out. So the teeth are all intact. And filled it up with buffer, because I think buffer sort of gets in there and helps to loosen the comb. So it's okay to do that first. And the other thing is everything is set. All the wells were set. I didn't have to move anything. You know, like the power supply's here. This is here. It's elevated so I could see better. Everything's optimal. So then I loaded the sample, and then we're ready. Then you load the sample, then you just go to running it in, and we want 10 volts per centimeter for running, but you run it in at a slightly lower voltage. We're running it in about 50, which is 5 volts per centimeter. And then for a half hour, and then we'll turn it up to 10, and then it'll run for about an hour, and that's it.